In this video, we will overview how to conduct an independent t-test. An independent t-test is used specifically when you want to compare means for two samples within your distribution or your data set. So in our case, we are going to compare males to females in the cognitive observation scores. In this case, we would not expect boys to differ from girls in how they perform the cognitive observational assessment because of equal opportunities to learn, to be taught, and to practice outside of class. Ideally, your instructions should carry on as if you were teaching everybody in a similar way, and by examining after instruction some assessments that capture progress that everyone should be expected to make, like the cognitive observational, the affective, observational and written, as well as the cognitive written test, for example. We would expect both male and female groups to perform equally as well. So the steps here would include going back up to the Analyze pull-down menu, choosing Compare Means, and the Independent Sample T-Test, or Independent T-Test. You would choose Cognitive Observational from the list to the right and put it into the test variable box because it is the dependent variable. And then you would choose Gender from the same box and place it into the grouping variable. Here you're also going to define what the groups are in terms of the numbers that you assign to them. So these boxes would be blank. You would type in 1, and then 2, and then continue. Press OK, and begin inspecting the output tables. The first thing you'll notice is the sample of males is 16, so there's 16 males in the sample compared to 14. And the mean for that group, the males, is 12.56 versus females 12.42. In this case, the means are almost identical, but we cannot be sure until we go and look at the test for equality of means, which is this right-hand side, or the center portion actually of this table. Here we can see the t-value for the analysis is 0.137, and the significance, or the p-value, as opposed to the t-value. The p-value here, we know significance is referring to the probability statistic, or the p-value. It is actually 0.89, which indicates there is no statistical significance, and the difference between these two means are no greater than what we would expect from chance, or in other words, sampling error.